Now, I always argue that we should not look at AI any differently than we look at software. The closer it is to a user, the better performance you get. Of course, just because piece of code or software is massive or monolith doesn't mean it is more powerful and more efficient. In most cases, a smaller, that's why we break it down, a smaller piece of code is better. Same way, you don't need large language model with massive billions and billions of parameters. Sometimes smaller models work better and they are most cost efficient as well. Another factor is culture, as we have seen a lot of cultural shift. DevOps, DevSecOps, SREs, all the label, all the personas are there. In terms of AI, how much role do you see culture, process, practices as we have adopted in the software world also play in AI world when it comes to taming cost?
I mean, to me, we have to look at the different cost factors that we use to model our business. Many times people will look at what is my return on investment? What is my total cost of ownership? How quickly am I scaling? And what is my cost of customer acquisition? Those are three numbers, sort of when you think about ROI, TCO, and CAC, that many people in SaaS environments are very used to looking at all the time. But if we think about where AI is a little bit different in this equation, it could be in the past using in its recent past, but using a non-AI centric workload that I would build in the cloud that I could scale more readily by deploying additional compute, deploying my microservices to additional environments that would help me with architectural availability and resilience, but it could also help me with latency and scale up if I needed to put my microservices in more places to accommodate more users or more concurrent users. The challenge when it comes to AI is that if you think about what you would need to put in multiple locations, a lot of companies don't have the experience. A lot of developers haven't yet figured out, as an example, can I afford to, or does it make sense to deploy my model in multiple locations? Because there's a fair amount of data, and you mentioned some of these very, very large models that people are used to licensing or used to referencing versus a small fine-tuned model that I might use for another purpose. Now, the first thing that I would say is make sure that you understand what model you're using for which purpose. If I am an industry or a domain specific application developer, and I need to make sure that my app is going to give me quick responses, it's not going to hallucinate, and I've got all of the specific information that I want coded into the model that I need, I might be looking at a fine-tuned or a domain or an industry-specific model that typically will be smaller than these frontier large language models because it doesn't need to be trained on all of the same things for me to address the use case for my domain or for this use case. That then also has to do with the size of the model. So if I have a fine-tuned model, it might encourage me or I might be tempted to deploy that in multiple places. But here's where we can run into a challenge. You can fix a distance problem with more compute if it's just pure and sheer compute power. If I need to keep my model up to date, continuously learning, if I need to think about the size of that model and how I'm moving data into and out of it, how that is going to relate to where I place the workload and where my GPU or CPU infrastructure is going to be for it, sometimes dealing with proximity by having copies of my model or my data in multiple places is just going to incur me a certain amount of additional cost because I'm going to pay twice for the same answer, arguably. If I could come to one model from multiple locations where the user is making a request, and I know that ultimately I'm going to be serving the same answer, but I'm copying that model to overcome a latency barrier, now I've accrued cost just to overcome latency by copying my model. And again, like that could be okay if you think about my model isn't really changing that much and I just need that proximity to maintain a latency budget. That's a consideration that you would make at design time or at architecture time, and then you can think about the cost that you would incur. But if I think about how workloads can become interactive and chatty, a lot of the interfaces for the use cases that modern AI inference are addressing are voice-based, are sort of video to text-based, or speech to text based, or real-time decisions like fraud interception, for example, or a voice agent. Those types of things need low latency. They need real-time responsiveness. And so if you think about concentrating that sort of a workload into centralized regions, it'll work great when people are close to that region, but your performance and your cost will suffer the further away you get because you will start to implement additional capabilities to overcome that latency, some of which could be, as we were saying before, copying that model. So I think the centralized cloud thesis makes sense if you have centralized functions that are sparsely or sparingly used that are not directly in the request response timing for an end user request, or if that request doesn't require real time. But if you need something like anomaly detection or fraud detection, or to provide somebody with a real time query based on something where they've already been conditioned to anticipate a real time response, then you need to be thinking about how am I going to have the orchestration capability to decompose a request and go to where the right information or the right code is being managed for my use case. And that is an extra layer of architectural consideration that goes beyond just how much do my tokens and how much do my GPUs cost.